Welcome to the MAN BMW Camshaft Flash engine, electronic engine, MEC engine. Here, module 3, we will discuss hydraulic power supply. Hydraulic power supply because the actuation of the FOPB, exhaust valve, cylinder lubrication is all carried out by hydraulic pressure, not by the mechanical force as was in the conventional engine because there no cam, no camshaft, no drive shaft, no nothing. So naturally hydraulic pressure is used. All right. So actuating force for fuel or pressure booster or the fuel pump equivalent to fuel pump in the MC engine is hydraulic pressure and not mechanical force, which is generated when roller guide rides the cam on a conventional engine. Here, hydraulic pressure is generated by the hydraulic pump, variable delivery piston pumps. However, the building up of the fuel pressure does take place more or less in a similar manner. In a conventional engine, we have a fuel pump where a plunger moves up in a barrel as pushed up by the cam. When roller of the fuel pump rides the cam, plunger moves in a barrel, and this there how the fuel pressure rises. And when the fuel pressure overcomes the spring pressure in the fuel injector, the fuel is injected. In fuel pressure booster in ME engine, similar kind of a plunger is moved upwards, or here you can say a piston also, piston or a plunger move upwards in a cylinder or a barrel when pushed upward by hydraulic pressure. This hydraulic pressure, of course, will be allowed the time decided by the ECU as conveyed to the CCU, and actual work carried out by the FIVA. FIVA will allow the entry of the hydraulic oil. All right. Exhaust valve actuator is also is a exhaust valve actuator piston is also move upwards when roller rides the cam, thus creating hydraulic pressure in the hydraulic pipe for opening the exhaust valve. Here also, it is the hydraulic pressure will move the actuator piston. Conventional engine, of course, we know it's the cam, exhaust valve cam, which move the piston up. Here, the hydraulic oil will move the exhaust valve actuator piston. So, exhaust valve opening mechanism remains the same. Opening is same because there is a hydraulic push rod. The hydraulic oil goes into the push rod and actually opens the exhaust valve. Similar way, it opens here also. But only when the piston move, that is instead of being cam, it is done by the hydraulic oil, hydraulic pressure. So the exhaust valve opening mechanism remains same and no change in the exhaust opening mechanism is carried out. However, the oil pressure in the hydraulic pipe is not created when roller rides the cam, but when the hydraulic pressure moves the two-stage piston upward and therefore generating oil pressure which opens the exhaust valve. So exhaust valve is exactly same as in the conventional engine. Hmm. But additionally, it has got feedback sensor because in these exhaust valve, these engines exhaust valve timings are controllable parameter. Opening and closing of the exhaust valve can be controlled. Exhaust valve can be opened, delayed, late opening is permissible, is allowed, is possible. Early closing of the exhaust valve is allowed, or late closing is also allowed. So, what is the effect of early closing and late closing? This question I have been asking earlier also. So, hey, now I give you the answer if you are not able to find the answer. I am sure you must have found the answer. If exhaust valve is closed early, the compression pressure will rise. If exhaust valve is closed late, exhaust compression pressure will drop down, will be lower. This phenomena is utilized later on when we are doing the performance. I will tell you. All right. So it's very useful phenomena. So this conventional engine, can we change the exhaust valve timing? No, not at all. It is more or less like having two cams, which can be changed anytime at will. Early closing, late closing, which is not possible in conventional engine. ME engine, it's possible. That is the beauty of this engine. So, exhaust valve timing can be delayed, not early. It can be opened. It can be start opening. It can be opened late, but not early, and it can be closed early and closer later also. Both are permissible, allowed, possible. Any questions? So hydraulic pressure is also required to operate alpha lubricator. Hmm. Therefore, we need hydraulic pressure to carry out these basic functions for fuel injection and exhaust valve operation, and also cylinder lubrication. Correct. So, how do we generate hydraulic pressure? So, in this module, we will learn developing the hydraulic pressure, which are the possible method, which are the pump, how the pumps are controlled, how controlling and managing the hydraulic pressure, the set point, and how that pressure which we have set at is maintained and controlled. Because I told you this pump which we are using are variable delivery piston pump. So delivery can be varied. So that variable delivery, the phenomena of variable delivery we use and control the hydraulic pump accordingly. Application of the hydraulic pressure in the ME engine, how this hydraulic oil or hydraulic pressure is utilized, used in the ME engine, this we will understand and learn in this module. Hydraulic power system, HPS. Actually, we call it hydraulic oil because it's actually carrying out the work which a hydraulic oil does, isn't it? Hydraulic, what is the function of a hydraulic oil? Basically, transmission of power, isn't it? So, but the here in these our engines, we take the oil from the main engine sum, which is the system oil, MECC, crankcase oil. So, system oil or sump oil is used to transmit the power, enabling the operation of various components. Therefore, even though the system oil is used, we call it hydraulic oil. It is possible to use a separate system, standalone arrangement for supply of this oil. Instead of using sump oil, you can use some other oil and have a separate system altogether. It is possible. It depends on the maintenance philosophy of the owners. What specifications were given to the shipyard? Shipyard can always provide you a separate standalone system for hydraulic oil or some drawn system also is possible. Most ships are using some drawn system for hydraulic pressure or using as a hydraulic oil. Some oil is drawn from the sump. A part of the sump oil goes for the lubrication of the various bearings and piston cooling as usual. Lubricant pump takes suction from the sump. One part goes to the bearing, piston cooling, etc. as normal, a conventional. Other part goes towards hydraulic oil. That oil quality and cleanliness has to be maintained. All right, very important. Cleanliness of the hydraulic oil must be maintained. Needless to say, the system oil being used for hydraulic oil needs to have excellent filtering arrangement. That's why an auto backwash filter is used with 6 micron filters. With a standby 25 micron filter, in whenever if something goes wrong with the auto backwash system, a standby 25 micron manual filter can be used, but that is only for temporary purpose. Temporary is a temporary solution, and meanwhile you must work out, rectify whatever fault is, and make backwash filter work because 6 micron filter must be working. Cleanliness has to be maintained. So, means some one side goes to the cooling and all, other side uh, filter goes to the sump oil, servo oil, or hydraulic oil. The engine-driven pump, which is attached to the engine, driven by the engine, either chain or gear shaft, and normally there are two, depending on the size of the engine, of course. There are two electric-driven pump, which are at the standby time when the engine is stopped. They will start up, build up the hydraulic pressure, and of course they will cut off when as the engine picks up RPM. That set pressure at which they cut off, that can be set in the engine control system. So this pressure 200 used to be, then 250, then most ships are maintaining 300 bar. So hydraulic oil passes through this double walled piping, and it goes to each what is we call HCU, hydraulic control unit. We will discuss the hydraulic control unit. Each unit has one HCU, hydraulic control unit, having fuel pressure booster, fuel the doing the work of a fuel pump, and exhaust valve actuator working doing the same work as the as the exhaust valve actuator in the conventional engine. Fuel oil here is supplied at 8 to 10 bar, which is normal. Supply and pump, fuel supply pump will supply the oil, will goes to the SCU, and here these are CCU, one for one unit, and of course alpha lubricator for each HCU. All right, we will discuss this also in a detail little later. Okay. So cleanliness of the hydraulic oil, which actually system oil, as I was telling you, is emphasized here, must be kept in mind. So cleanliness must be as per the ISO 4406 standards, and acceptance criteria is XX/16/13. Oil after the hydraulic filter should meet the criteria as stated. What it means actually is the particle size of 2 micron, XX, some number, particle size of 5 micron, and particle size of 15 micron. Particle size of 15 micron should not be more than 13, particle size of 5 micron should not be more than 16, and particle size of 2 micron should not be some number. Respectively must not be more than 16, 13, excess 16 or 13. 5 micron size particles, not more than 16, 13 micron, not more than 15. That is in 1 cc of the unit, 1 cc. So this can be checked out only when you send oil for analysis. So these numbers are not the exact numbers of particles, though it is somewhat complex process. How the test results arrive at these numbers, because what method they are using, it depends on that also. For a marine engineer, test result which meets the above criteria shall suffice. Cleanliness standards of 4406 can be learned and found out from the other sources also. Its information is available on net or certain books, also some books in the library also. ISO standards are now actually they are saying go not higher up and follow ISO 4407 standards, which actually is the test standard, analysis standard. The way the analysis is carried out, that parameters have been changed in the way the microscopy analysis that has been the method has been changed. That's all. So for us, we are concerned about the test result, analysis result, not really concerned about how the test is carried out, unless you want to work in the lubal industry, tribology. All right. Depending on the engine size, a number of motors driven hydraulic pump and engine driven hydraulic pumps are used. Using two numbers of electric motors driven pump to build up the pressure of 300 bar when engine is stopped, or actually 250 is also enough when engine is stopped, is very common. And three engine driven pumps is also very common. Or sometimes five also. We will discuss a scenario where will be using two electric driven pump, five engine driven pump. All right. I'll tell you how this five engine hydraulic pump will be controlled. When engine picks up RPM, engine driven pump usually three numbers. It can be five also. Take over and motor driven pumps are stopped. Engine driven pumps are gear or chain driven. It also possible to have all electrical pumps. Smaller engines, yes, all electrical driven pumps are possible and are in fact used. And these driven pumps have what we call weak link. So instead of in any load comes on the pump for whatever reason, instead of getting the pump, instead of allowing the pump to get damaged, a weak link will break. The chain will break or the gear drive shaft will break. So the pump will be saved from damage. So what types of pumps are used? Hydraulic pumps, whether driven by electric motors or engine driven, are variable delivery axial piston pump. Variable delivery axial piston pump. As the name implies, delivery can be varied from 0 to whatever the pump design capacity is. Any pump, when pumping, will have a suction side, this kind of axial piston pump, that means suction port, and also a discharge side, discharge port. So engine-driven pump, when running in a given direction, say ahead, will have one port as suction and another port as discharge port. Correct? But now the question arises, since these pumps are attached to the engine, what happens when the running direction of the engine is reversed? Let's say now running in the eastern direction. So, don't you think the port of the hydraulic pump will also change? The side which was suction side will become a discharge side because the direction of rotation is reversed. Pump will be running in another direction, and the side which was the discharge side will become suction side. In unwarranted situation, we don't want that. So what to do? So what happens when direction of rotation of engine is reverse, changed from ahead to stern? So when engine running direction changes from ahead to stern direction, the suction discharge port will also get reversed. This means the suction port will become the discharge port, and the discharge port will become suction port. As I said, we don't want that, do we? No. So what do? We control the pump. There is a method, there is a device which controls the pump. You see that? So we need to ensure the suction discharge port remains same, no matter what direction of the engine is, ahead or stern. Even when pump has changed its direction of rotation, since it is attached to the engine and engine direction of rotation has changed from ahead to stern or vice versa, we need to ensure suction and discharge port do not change. We'll see just in a while. So first, let us continue with the hydraulic power system. So hydraulic pressure, thus generated, goes to the hydraulic control unit, SCU, distribution block through double wall pipe. So I will just discuss, I will tell you, we'll talk about this suction and discharge port little later. But first we finish talking about the hydraulic pump unit. So it has a distribution block and through double wall pipe. The double wall hydraulic pipe is for obvious reason because pressure at a high pressure 250 to 300 bar is passing through them, and it's possible that some leak can be developed, may happen, or pipe may go develop pinhole or something. So these double wall pipes, if develops a leakage, there are leakage sensor in the double wall pipe present. They'll give you some alarm. They will give indication. First, they will give alarm. If the leakage persists, it gives you a slowdown. A slowdown can be a cancelable slowdown. If leakage persists or quantity increases then more than certain quantity, a shutdown can also occur. And shutdown can also be a cancelable shutdown because suppose it happened during maneuvering. So for time being, you will live with leakage, but you do not want the engine to stop. So all these things will also discuss later when slowdown or shutdown alarm system we are discussing. So meanwhile, remember this, that leakage sensors are fitted in double wall casing on a hydraulic pipe. So double wall pipes are leakage sensor, as I was telling you. A cancelable slowdown and shutdown occurs in case leakage persists for more than a given time. A method of detecting leakage between which two SU has occurred is also given in the shipboard manual. Of course, each unit has its own SU. This is also interesting. You must read about this, how to find out where the leakage has occurred. Which two HCU leakage has occurred. There is a method available because all SCU have arrangement, walls and all, so you can regulate the walls, close the wall. Of course, you can do it only in the port. Stop the engine, run the hydraulic pump, engine motor driven, and then you carry out the test. Close this valve one, close the valve in the end, and then put the pressure gauge. All these points are available where you can fit the pressure gauge and all. Then you can check the parameters and continue. There's a method. If I got time, I will also explain to you. But this is not for any engine. This is a general guidance. Any engineer will know. So you can be found out. All right.